The Japanese have hidden a technology in a tank that no other country in the world possesses, almost $10 million for a single tank. This is not a typo or a joke. That is exactly how much the Japanese Type 10 main battle tank costs, making it the second most expensive tank in the history of mankind. But why pay such insane sums when you can buy the battle-proven American Abrams or the German Leopard for half the price? The answer lies in a secret technology that Japanese engineers developed over decades and which is still not available to any other country in the world today. To understand how Japan came to create this steel monster, however, we must return nearly 100 years to an era when Japanese tank crews accomplished something incredible, before their own command destroyed everything they had achieved. The year 1937. China. The Battle of Rehe. Japanese troops invaded the enemy's territory and encountered a powerful defensive line of the Chinese army. Infantry attacks stalled, losses mounted, and then the command made a decision that changed the course of the battle. Small Japanese tanks of the Type 89, machines weighing only 12 tons, were ordered to break through the enemy's second line of defense. The tank crews fulfilled the task brilliantly. The armored vehicles raced through the Chinese positions, sowing panic and chaos, while the infantry rushed into the gap that had been created. This was a classic tank attack with a deep breakthrough. The most amazing thing was that the Japanese performed this maneuver several years before the Germans became famous for their lightning-fast blitzkriegs in Europe. It seemed as if Japan had found the key to victory. The tank units proved their effectiveness. Tank officers developed a new doctrine. Engineers worked on more perfect machines. But then a catastrophe occurred, and one man was to blame: General Hideki Tojo. This staunch supporter of infantry tactics came to power and began methodically destroying everything connected with the tank forces. He believed that a true Japanese warrior should fight with a rifle and bayonet and must not hide behind armor. Tank units were disbanded, funding was cut, and officers who advocated for the development of the armored forces were transferred to secondary posts. The consequences of this decision were horrific. When Japan encountered American troops on the islands of the Pacific Ocean, its tanks looked simply pitiful compared to the American Shermans. The Japanese machines were pierced right through. Their thin armor could not even withstand the fire of large-caliber machine guns, and the weak guns could not cause any serious damage to the enemy. By 1944, at the peak of war production, Japan was only able to produce a total of 925 armored vehicles. By comparison, the Soviet Union produced about 29,000 tanks and self-propelled guns in the same year. By 1945, Japanese production collapsed to 256 armored units per year. This was a total catastrophe that had to be paid for with the lives of thousands of Japanese soldiers. After the surrender in 1945, Japan found itself in a unique position. The 9th article of the new constitution forbade the country from having full-fledged armed forces. Only self-defense forces for the protection of its own territory were permitted. No offensive operations, no military bases abroad, no ambitions of a great power. It seemed that Japanese tank construction was dead forever and would never rise again. But the Cold War brought its corrections. The Soviet Union rapidly built up its military power in the Far East. Thousands of tanks stood in garrisons along the border, and American strategists seriously feared an invasion of the Japanese islands. Washington put pressure on Tokyo, and the Japanese had to urgently create their own armored forces. At first, these were American machines handed over under a military aid program, followed by licensed production, and finally, Japanese engineers began to develop their own projects: Type 61, Type 74. Each new tank became more perfect than the last, but they all remained in the shadow of their Western counterparts. The Japanese learned, gained experience, accumulated technologies, and waited for their hour. That hour struck in 1990 when the Type 90 tank was put into service. the first truly modern Japanese combat machine capable of fighting on equal terms with the best tanks in the world. 50 tons of armor and steel, a powerful 120mm cannon, an advanced fire control system. The Type 90 was created specifically for the confrontation with the Soviet T-72, which could have landed on the northern island of Hokkaido. However, this tank had a serious disadvantage that the Japanese military realized too late. 50 tons of live weight. That is exactly how much the newest Japanese Type 90 tank weighed. And it was this figure that became its curse. When the engineers at Mitsubishi designed this machine, they thought of only one thing: how to stop Soviet tank columns on the snowy plains of Hokkaido. The northern island, with its mountains, swamps, and vast open spaces, was ideal for heavy armored technology. Here, one could set up a classic tank defense, use the relief of the terrain, and lay ambushes in mountain passes. But the Japanese strategists made a critical mistake. They forgot the rest of their country. The Japanese islands are crisscrossed by a network of almost 18,000 bridges. Narrow mountain roads, old river bridges, tunnels, and overpasses. The entire transport infrastructure was created for civilian needs and not for the movement of heavy military equipment. When the military tried to move Type 90 tanks from Hokkaido to other islands, they encountered an unpleasant surprise. The 50-ton steel giant could safely travel over only 40% of Japanese bridges. The remaining 60% simply would not have withstood its mass. Of course, a bridge does not collapse instantly when the permitted load is exceeded, but in peacetime, no one intended to risk expensive equipment and the lives of the crews. And in wartime, a destroyed bridge would mean the loss of a critically important transport artery. This problem was felt particularly acutely on the southern islands of the Ryukyu archipelago, a chain of tiny patches of land stretching from Kyushu almost to Taiwan. Narrow roads, weak bridges, extremely difficult terrain. It was practically impossible to move heavy tanks here. And it was precisely these islands that suddenly found themselves at the center of a geopolitical storm that overturned all of Tokyo's strategic calculations. The Soviet Union collapsed in '91, and the threat from the north diminished sharply. But a new, rapidly growing China replaced the old enemy. Beijing modernized its fleet, built up its marine infantry, and made increasingly loud claims to disputed territories in the South China and East China Seas. The Senkaku Islands, which the Chinese called Diaoyu Dao, turned into a constant source of tension between the two powers. Chinese ships regularly entered Japanese territorial waters, and military analysts in Tokyo seriously discussed the possibility of a landing operation on the southern islands. The Japanese strategists realized a terrifying truth. Their country has practically no defensive depth. What does this mean in practice? In the event of an invasion, there is simply nowhere to retreat. Ukrainian troops could withdraw hundreds of kilometers deep into their territory, stretching enemy communications and wearing down the opponent. The Japanese do not have such a luxury. At any point in the archipelago, the ocean is less than 160 kilometers away. The enemy lands on the shore, and you are already fighting with your back to the water. Every meter of territory becomes critically important. Every defensive position must be held to the last. Under such conditions, a completely different tank was needed. Light, mobile, capable of being quickly moved throughout the archipelago and taking up defensive positions before the enemy could establish a foothold on the shore. In 2002, the Mitsubishi Heavy Industries Group received a secret contract to develop a fundamentally new combat vehicle. The project was given the code name MBTX, and its parameters seemed almost impossible to the engineers. The military demanded the impossible: to create a tank that would weigh significantly less than 50 tons, but at the same time would not be inferior in protection and firepower to the best Western models. The machine had to be able to pass over most Japanese bridges, be easily transported by standard means of transport, and be immediately ready for use on any section of the coast. At the same time, the tank was to carry a powerful gun capable of piercing the armor of the newest Chinese and Russian machines. Mitsubishi was not facing such challenges for the first time. This corporation, which was founded as early as 1884, had developed into the 23rd largest defense contractor in the world by the beginning of the 21st century. It was precisely in the Mitsubishi plants in Nagasaki that the warships of the Imperial Fleet were built. And that is exactly why the Americans chose this city as the target for the second atomic bomb in August 45. Now, the descendants of those engineers had to create a weapon that would protect Japan from new threats. Work on the MBTX project proceeded under the strictest secrecy. The engineers experimented with new materials, calculated variants of the design, and looked for ways to reduce weight without loss of protection. They knew that they were not just building another tank. They were creating a machine that was to trigger a revolution in tank technology. In 2006, the first prototype rolled out of the factory gates. 40 tons in the minimum configuration. The Japanese engineers had succeeded in the impossible. The new tank weighed 10 tons less than its predecessor, and that changed absolutely everything. At this weight, the vehicle could safely travel over 84% of all Japanese bridges, while the 70-ton American Abrams could only manage 40%. The true revolution, however, was the concept of modular armor, which no tank in the world had used before. The designers at Mitsubishi proposed a brilliant solution: 3 weight configurations for one machine. In the minimum configuration, the tank weighs 40 tons and is intended for rapid movement over roads and bridges with limited load capacity. The standard combat configuration adds additional protection modules and brings the weight to 44 tons. This is sufficient for most combat situations. The maximum configuration with reinforced armor blocks on the entire hull results in 48 tons, and even that is significantly lighter than most Western counterparts. This approach allowed commanders to adapt the equipment to the specific task. Does a tank company need to be moved urgently over narrow mountain roads to a remote island? We take off the additional modules and send the machines in the lightened version. Are we preparing for coastal defense against a landing with heavy armored technology? We attach the maximum protection and dig in at the positions. No other tank in the world offered such flexibility in application, but reducing weight was only half the task. The Japanese islands consist of mountains covered with forests, narrow valleys, terraced rice fields, and endless climbs with steep descents. A conventional tank with a rigid chassis turns into a clumsy dinosaur under such conditions, unable to aim normally on a slope or use natural cover. The engineers at Mitsubishi solved this problem using an advanced hydrop pneumatic chassis, which transformed the Type 10 into a true acrobat. The system allows the crew to instantly change the height of the hull and tilt the machine in any direction by raising or lowering individual road wheels. In practice, this looks almost fantastic. The 40-ton steel giant can literally bow, crouch to the ground, or raise its nose. Video recordings of tests in which the tank writes Japanese characters with the gun barrel went through the entire internet and forced military experts worldwide to acknowledge the Japanese have created something unique. But behind these effective tricks lies a deadly serious combat potential. When the tank fires from a hill or from behind an embankment, the ability to tilt the hull allows for maximum use of cover by letting only the turret with the gun protrude over the obstacle. The enemy sees a minimal target, while the Japanese tank soldier maintains the full firing sector. When firing on a slope, the chassis automatically compensates for the inclination of the terrain, keeping the gun in a horizontal position and ensuring precise aiming where a conventional tank would be forced to drive out into the open. Testing of the new machine began in 2008 on the training grounds of the Self-Defense Forces. Tank crews practiced interaction in battle, mechanics studied the features of maintenance, and engineers collected data on the reliability of all systems. Particular attention was paid to the electronic interior, which raised the Japanese tank to a completely different level compared to the competition. Each machine was packed with computers, sensors, and communication systems that transformed a single tank into a node in a reconnaissance and strike network. The tests were completed at the end of 2009, and the results exceeded all expectations. The Ministry of Defense of Japan officially put the machine into service in 2010 and gave it the designation Type 10. By the spring of 2020, the Japanese industry produced between 76 and 106 units of the newest tanks, which gradually replaced the outdated Type 74 and supplemented the heavier Type 90. The main secrets of the Japanese tank, however, were not hidden in its chassis or even in the modular armor. The true technological breakthrough was the armament that the company Japan Steel Works created for this machine, a legendary manufacturer whose history goes back to the beginning of the 20th century. It was precisely this plant that manufactured the gigantic gun barrels for the battleship Yamato, the largest warship in history. And it was exactly here that the cannon was developed that put the Type 10 on a par with the best tanks on the planet. The 120mm smoothbore gun Type 10 looks shorter than equivalent cannons on the Abrams or Leopard. 44 calibers in barrel length compared to 55 calibers for the German Rheinmetall cannon. Apparently, a shorter barrel means a lower muzzle velocity of the projectile and worse penetration power. But the Japanese metallurgists had a surprise in store that amazed the whole world. 640 megapascals of pressure in the chamber of the gun. No other tank barrel in the world can withstand such a figure, except the Japanese one. By comparison, this pressure exceeds the values of American and German guns. The secret lies in a unique technology that the engineers at Japan Steel Works developed over decades. This company, founded in 1907, became famous for the production of high-purity steel using a special technology that remains a trade secret to this day. Every year, the plant brings out a limited batch of traditional Japanese swords. The masters claim that the modern steel from Japan Steel Works is in no way inferior to the legendary blades of the old armorers. Exactly this metallurgical magic allowed for the creation of a gun that works at the limit of physical possibilities. Special alloys withstand the enormous pressure of the powder gases, which would tear the barrels of an American Abrams or a German Leopard apart from the inside. Since one can increase the pressure, one can accelerate the projectile to a speed that is unattainable for other tanks. The result astonished even the developers. The muzzle velocity of an armor-piercing shell from the Japanese gun reaches 1,780 meters per second, which exceeds the values of the praised Abrams. However, the Japanese went even further and created a special ammunition that is only suitable for their gun. The armor-piercing, fin-stabilized sub-caliber projectile, which also received the designation Type 10, weighs 7.8 kilograms and contains an increased powder charge. The pressure in the chamber when firing is so high that this ammunition is physically impossible to use in other NATO guns of 120mm caliber. Their barrels would simply burst. The Japanese Ministry of Defense keeps the exact data on the penetration power of this projectile under the strictest secrecy, but Western experts estimate its capabilities as comparable to the best American and German ammunition, possibly even exceeding them. The entire firepower is supplemented by an autoloader that is conceptually similar to the system of the French Leclerc tank. 14 shells are located in the mechanism of the autoloader, ready for immediate use. 2 more shells are stored behind the back of the gunner, and 6 additional ammunition units are housed in a compartment next to the driver in the front part of the hull. The entire ammunition supply is 36 rounds, less than the 45 shells in the Russian T-72. But the Japanese military consciously decided on this restriction. The logic is simple. The tank is created exclusively for the defense of the home islands. The machines will always fight not far from supply bases and will be able to quickly replenish the ammunition supply. Unlike an attacking army that has to pull long supply trains behind it, Japanese tank crews will protect their land and will always be able to count on nearby ammunition depots. On the other hand, the rate of fire of the system is impressive. One shot every 3.5 seconds, which is faster than its predecessor, the Type 90. In addition to the main caliber, a coaxial machine gun of 7.62 mm caliber and a heavy machine gun of 50 caliber on the commander's cupola adorn the turret of the tank. When all three weapon systems open fire simultaneously, the sight resembles scenes from science fiction movies. Streams of tracer ammunition shoot from all barrels of the machine toward the target. But even the most powerful gun is useless without reliable protection for the crew. And here, the Japanese played their trump card, the mysterious nanocrystalline steel that became the hallmark of the Type 10 tank. What is this material that the specialists at Japan Steel Works are advertising? The exact composition and production technology are secret, but open sources point to a steel with a special structure that is 3 times harder than conventional armor. Under layers of composite protection is a base made of this unique material, which offers more protection per kilogram of weight. Critics point to the visually weak side armor of the tank, but experts respond, what is shown at parades and exhibitions can differ greatly from the real combat configuration. The Japanese military does not reveal all secrets, and demonstration models could well carry lightened modules instead of full protection. In addition, the Type 10 was created for a specific tactic. The machine will stand in a trench or behind a concrete wall and present only the powerful front section to the enemy. Side armor does not play a decisive role in such a situation. The Ministry of Defense conducted tests in which the tank was fired upon from a distance of 250 meters with armor-piercing shells, practically at point-blank range by tank protection standards. The results are secret, but the official statement says that the composite armor demonstrated the required characteristics and exceeded the heavier Type 90 in the protection of the front section. Laser warning receivers are installed at all 4 corners of the turret, which instantly warn the crew if an enemy has targeted the machine. This system gives valuable seconds to move out of the line of fire or set a smoke screen. 1,200 horsepower under the armored hood. An 8-cylinder diesel engine accelerates the 40-ton Colossus to 70 kilometers per hour on the road. But what makes this tank truly unique is not the forward speed, but the reverse speed. Thanks to a continuously variable transmission, the Type 10 is able to drive backward at the same speed as forward, 70 kilometers per hour. No other tank in the world dreams of that, and this feature transforms the Japanese machine into the ideal tool for a tactic that tank soldiers call shoot and scoot. Imagine the battle scene. The Japanese tank shoots out from behind cover. Its fire control system instantly captures the target. The gun spews a deadly shell, and the machine rolls backward at full speed and disappears behind a fold in the terrain before the enemy can align the weapon for a counterstrike. The exposure time is reduced to a minimum. The chances of taking a hit drop many times over. The faster the tank returns to cover, the more effectively this tactic works. The Type 10 is unsurpassed in this regard. The ratio of engine power to mass is 27 horsepower per ton, an excellent value that gives the machine rapid acceleration dynamics and excellent maneuverability. By comparison, the heavy Abrams has a significantly lower value due to its enormous weight of 70 tons. The Japanese engineers relied on mobility instead of thick armor. On the limited space of the home islands, this philosophy works perfectly. But the true revolution is hidden not in the mechanics, but in the electronics. Already in the design phase, the Ministry of Defense insisted on the introduction of the most modern systems for command, control, communication, computerization, and intelligence, what is referred to in military jargon by the abbreviation C4. When the machine was officially put into service in 2012, it already carried advanced electronics on board that were ahead of their time. Each tank's onboard computer is capable of simultaneously detecting and tracking up to 8 targets in the sector of view. Information about coordinates, type, and status of the enemy is automatically transmitted to the unit commander and all vehicles in the platoon. A loaded database allows the system to independently identify enemy technology by its silhouette. T-90 or Chinese Type 99 are recognized immediately, and the crew receives data on the most vulnerable zones of the enemy armor. But the most elegant function of this system is the automatic distribution of targets between the vehicles of a unit. The computer of the commander's tank analyzes the situation and assigns priority targets to each team so that 2 tanks do not accidentally fire on the same enemy vehicle. This coordination happens in real time, without voice radio, which is critically important in the chaos of a modern battle. Data on positions, the condition of the machines, and discovered targets can be passed up the command hierarchy to the corps level, creating a unified situational picture for all leadership levels. The interaction with infantry and artillery reaches a new level. Tank crews can transmit target coordinates to artillery batteries, receive data from infantry scouts, and coordinate actions with attack helicopters. For a country that historically had limited experience in tank operations, the introduction of such an advanced network architecture means a gigantic leap in tactical competence. But even the best electronics and the most powerful gun do not save a tank from modern threats if it cannot protect itself against missiles and drones. In 2022, video recordings of tests of an active protection system on the chassis of the Type 10 appeared. Specialists noted potential mounting points for a complex capable of intercepting incoming grenades and anti-tank missiles. The Japanese military may be counting on being able to provide the machine with all-around protection against projectiles and missiles as these technologies mature, without increasing the mass through additional armor. The question of price remains a matter of debate. Almost $10 million per unit are colossal sums. However, economists point out that every dollar spent on one's own production remains in the country. Jobs in the Mitsubishi and Japan Steelworks plants, taxes for the state treasury, development of critical technologies, independence from foreign suppliers. All this is acquired along with the tank. In the event of a war, Japan will not be confronted with a situation where allies refuse to supply spare parts or ammunition. Every component of the machine is produced on home soil, which is an invaluable advantage. From the ignominious defeats of the Second World War to the creation of one of the most technologically perfect tanks on the planet, Japan has traveled an incredible path. A country that was forbidden to have an offensive army has built a defense machine capable of stopping any aggressor on its shores. Nanocrystalline steel, an overpowering gun, a network architecture of the battle. All these technologies make the Type 10 a worthy opponent for any adversary.